Okay, our key question for today's lesson is what models can we use to rename fractions greater than 1 as mixed numbers? So when we have a fraction greater than 1, we can represent it as a fraction or as a mixed number. A mixed number has a whole number part and a fraction part. Let's look at 10/3 represented as these two different number bonds. Both number bonds show the total 10/3 decomposed. One number bond shows 10/3 decomposed into 4 parts, where 3 of the parts are 3 out of 3 and 1 part is 1/3. The other number bond shows 10/3 decomposed into 2 parts, where 1 part is 9/3 and 1 part is 1/3. Let's show these bonds as equations. The equation for the first number bond is 3/3 plus 3/3 plus 3/3 plus 1/3. From these equations, what fraction can you rewrite as a whole number? Think about that as we look at the second number bond equation. We have 9/3 plus 1/3. Some of the fractions in these equations can be rewritten as whole numbers. Three-thirds, or 3 out of 3, is equal to 1 whole, and 9/3 is equal to 3 whole. So when we rewrite the equation as 1 whole plus 1 whole plus 1 whole plus 1/3 and 3 whole plus 1/3, let's continue rewriting these equations to simplify them. So now we have 1 plus 1 plus 1 equals 3, and then we bring down the 1/3. This one just became that mixed number, 3 and 1/3, and now we have 3 and 1/3. So we can rewrite 3 plus 1/3 as a mixed number or a whole number and a fraction less than 1. We say this mixed number as 3 and 1/3. The word "and" indicates that we add the whole number and the fraction less than 1. Both of these number bonds work to rename 10/3. However, if you already know that 9/3 is 3, then the second number bond only has 2 parts that might be more efficient. Instead of using number bonds to represent the decomposition of fractions and renaming it as a mixed number, let's use a number line. Here we need to remake 14/4 as a mixed number. The fractional units is fourths, and 4/4 make 1. If we know 4/4 make 1, we can skip count by 4/4 until we're close to 14/4. 4/4 equals 1 whole, 8/4 equals 2 whole, 12/4 equals 3, and 16/4 equals 4 whole. This tells us that 14/4 will be between 3 and 4 on the number line. Let's partition the number line into 4 equal parts and label the whole numbers from 0 to 4. Then we're going to partition each whole into fourths. Just did that. We know where 12/4 on the number line is because 12/4 is equal to 3 whole. 14/4 is just 2/4 more than 12/4, so 14/4 is 2 tick past 12/4 on the number line. 2 jumps. 1, 2. Now let's shade our number line to efficiently decompose 14/4 into 2 parts. There are 3 groups of fourths on the number line before 14/4, so let's shade the number line from 0 to 3. Let's write an equation to show 14/4 decomposed into a sum of 2 fractions. At first we shaded 12/4, then we shaded 2/4, so 14/4 equals 12/4 plus 2/4. Let's rewrite the equation, renaming 12/4 as a whole. The mixed number that we can write for this fraction is 3 2/4. Thinking about 14/4 as 3 2/4 can help you locate 14/4 on a number line more easily. Instead of counting to 14/4, we can get right to the 3 whole and then count 2 more fourths. So 14/4 rewritten as a mixed number is 3 2/4. Let's try renaming another fraction as a mixed number. This time we will do 15/6. For this number line, we know that 6/6 is equal to 1 whole, and 12/6 is equal to 2 whole, and 18/6 is equal to 3. So 15/6 is going to be somewhere between 2 and 3 on the number line. We can partition our number line into 3 parts and then partition each whole number into sixths. Let's label 12/6 on the number line. 15/6 would be 3 jumps past that. 1, 2, 3. And now we shaded in to show how we're decomposing 15/6 on the number line. Now let's write an equation to show our work so far. 15/6 is equal to 12/6 plus 3/6. We can rename 12/6 as a whole number, and in this case it's 2 whole. 15/6 is equivalent to 2 3/6. So while you're working on your guided practice, make sure that you can think about how to efficiently rename fractions greater than 1 as mixed numbers, trying to find those wholes and pull them out. Good luck!